and magnetism. Okay, electricity and magnetism. Okay, so okay, so 6.1 generation of electricity. So how does we generate the electricity that we use, okay, at our home? Okay, so but at first, okay, let's see the type of energy first. Okay, so the first type of energy is renewable energy sources. Okay, so what is the renewable energy sources? Okay, the energy that can be replenished or renewed, okay, when they have been used, so it will not finish, okay, it will always be there. All right, and then the example of the renewable energy sources is a hydroelectric. So hydro means water, right? So wind energy, okay, tidal energy, biomass energy, solar energy, firewood, geothermal energy. So this is the example of the renewable energy sources. Okay. All right, and then the second one is the non-renewable energy. So what is the non-renewable energy? So energy that cannot be replenished or renewed or will eventually be used up and exhausted one day in the future. So means one day it will be finished. Okay, there will be no more of this type of energy. Okay, so example of it is fossil fuels. Okay, coal, petroleum, natural gas, radioactive substance. Okay, so fossil fuel is the fossil fuel is actually used to produce the petroleum, right? Okay, and the radioactive substance, the examples such as plutonium, krypton. Okay, so that one is to produce the nuclear energy. Okay, renewable energy sources. Okay, so geothermal is to produce the heat energy. Okay, and the sun is to produce the solar energy and also to produce the heat energy. Okay, and wind is to produce the wind energy. All right, and the wave and the tidal to produce the potential energy and the kinetic energy. Okay, and the water to produce the hydroelectric energy. Okay, and the biomass to produce the biomass energy. So this one biomass, it will produce the methane gas. Okay. All right, what is the generator? Okay, what is it, the generator? So generator is actually a device. Okay, so a device that used to generate the electricity. Okay, so it's a device to produce the electricity, okay, in process of generating electricity. Okay, so generator is actually used to produce, okay, the electricity. So this is the example, okay, of the generator. Okay, this one is actually by using the magnet. All right, so and then you connected the magnet with the wire to the LED. Okay, and then there's a crank there, and there will be a coil of wire. Okay, so this one, it can produce the electricity, it can produce current. Okay, so but this type of current, okay, but this type of current is actually the induced current. Okay, so this type is actually a induced current. So induced current, normally in our home we don't use induced current. Okay, so this one is actually the other way to produce the induced current, to produce a current, okay, either than you use the power station. So this one is actually by using the magnet. Okay, by using the magnet. The one that we use is actually by using the hydroelectric. Okay, so that one is different, but this one we use a magnet. So what is it, induced current? Okay, so let me explain first what is it induced current. Okay, so let's say if I have a magnet here, okay, a permanent magnet, right? So north and south. So you already know, okay, the magnetic fields for the permanent magnet, okay, it goes, the direction is from north to the south. Okay. So from north to the south. Right. So and then I have a conductor. Okay, a conductor. So it may be made from the copper. Right. And then I connected it to the galvanometer. Okay, so what is it, the galvanometer? Galvanometer is actually to measure induced current. So what is the difference between the galvanometer and the emitter? Because emitter also we already know that that one also used to measure current, right? But why we didn't use emitter here? But why we use the galvanometer? Okay, for the galvanometer, all right, the scale is the zero scale is at the middle here. Okay, if the normal emitter you already know is the starting point is here, right, zero. But for the galvanometer, the zero start in the middle. Okay, so means the pointer can deflect to the right or to the left. Okay, to the right or to the left. Okay, so this one it depend on the direction of the current. Okay, whether it flows for this one, whether it flows to the right, or this one is close to the sorry, if this one flows to the left, or this one flows to the right. So it depend on the direction of the current. Okay, but for this one, because you already know, okay, for the emitter that we use in the electric circuit. Okay, so let's say this is a battery and I have an emitter here. Okay, and you already know that the current will always flows from positive to negative, right? So means the emitter will always deflect in this way. Okay, it will always deflect into this way. Okay, but for this one we don't know. Okay, we don't know because we don't know which one is the positive and which one is the negative terminal, right, in this case. Okay, so if we don't know means we have to use the galvanometer to know which is direction of the current. Okay, but for this one in the normal circuit that when you, I think you already learned in form 2, right, the Ohm's law, that one, you already know the current flows from positive to negative. So in the direction will always be same. But for this one, we don't have the terminal positive and negative. So we don't know the direction. So that's why the galvanometer, the scale or the starting point, the zero starting is at the middle. So we know whether it deflect to the right means the current flows to the right. If the deflect to the left means the current flows to the left. Okay. All right. So that's the okay. So that's the why this is why we use the galvanometer. Okay. Then I want to explain how does the induced current, okay, can be produced by using this apparatus. Okay. So this one you already know they have a magnetic field lines. Okay. So this is the conductor, right? So what the conductor will do, it will cut the magnetic field line. So means the conductor have to move up and down. Okay, up and down, so it can cut the magnetic field lines here. Okay, so when it cut the magnetic field lines here, it will produce the induced current. Right, it will produce the induced current. Okay, if the conductor move left and right, okay, left and right, there will be no induced current produced. Okay, because the magnetic field line is not being cutting. Only you have to cut the magnetic field line, then it will produce the it will produce the induced current. So this is different from the current like you use in our house. Okay, that one we don't use magnet. Okay, for the one that we use in our house, we don't use magnet. Okay, that one we have to generate by the generator. Okay, they have a turbine there. Okay, so it's different. Okay, so for induced current, and also for induced current, the amount of current produced is very small, so it will not be enough, okay, to use in our house or in our factory. Okay, so that's why we use the we generate using the power station, right? So for this one is just to just let you know that actually you can produce the induced current, okay, by cutting the magnetic fields lines. Okay, so and then the galvanometer will show which direction the currents flows. All right, so that is the induced current. So remember, to produce the induced current, the magnetic fields must be cut. Okay, so it can produce. Okay, and you have to use the galvanometer. So let's see the video here. Right, so let's see the video first. So electromagnetic induction.
In part 1 of electromagnetic induction, take a
Okay.
simple experiment and explanation.
Alright, so this one I just mute, I will explain. So this one is a moving a single line in a magnetic field. So let's see the video for the moving magnetic field fields line in the moving a conductor in the magnetic fields lines, right? Okay, so you can see here, right? So this is the conductor. Okay, so this is the conductor, and you can see there is a magnetic fields here. So actually you cannot see it in your with your eyes lah, but we just imagine. Okay, but you can see by using the metal by using the metal powder, right? So that one you can see the pattern. Okay, you just use the metal powder on the magnet, you can see the pattern of the magnet. Okay, and it flows from the north to the south, right? So you can see here it cutting the magnetic field line, and you can see the galvanometer. Okay, you can see here the galvanometer is the scale is 0 is starting at the middle here, so you can see it deflect, right? So it deflect. Okay, so this is actually the induced current. Okay, you cut the magnetic field line to produce the induced current. Okay, so what happens if I move up the magnetic fields? Okay, sorry, I move up the conductor. All right, so it going up now. So what will happen to the galvanometer? You can see just now it deflect to the right. Okay, so when you change the direction, you go up. Okay, you bring the conductor. Okay, you cut it. Okay, in the opposite way. So you can see the deflection of the galvanometer is in opposite way. It's go to the left. Okay, so means this one it shows the direction of the current. Okay, so means this one the direction goes here and then goes here, and we complete the circuit. Just now when you go down, when you cut it down, okay, so it moves from here, the current goes here and goes here, and okay, and complete the circuit like that. So you can see there is no dry cell involved on this one. Okay, so the current is only produced by the cutting of the magnetic field, right? So that is the induced current. Okay, so I move on to the next slide. So this one we already discussed. Okay, so induced current. So investigation of Michael Faraday. So that one is the scientist that found the induced current. So that is a Michael Faraday. Okay. So how before we learn that to produce the electricity, okay, you need to know the power station. There's a many type of power station. Okay, so either then you use the power station to generate electricity. Also, we can use the induced current also. Okay, but like I said, the amount of current produced is very small, so it's not enough. Okay, but you have to know there are two ways to produce the current. Okay, so the first one by the power plant, okay, by the power plant, and the second one is by using the magnet and cut it off and produce the induced current. Okay, so this one is actually the generation of electricity using a magnetic fields, okay, by the movement of wire. Okay, so like you noticed before, okay, so to produce the induced current, okay, there will be need a movement. Okay, it's whether the magnet move or the conductor move, right? As long the magnetic field is being cut, okay, you can just let the current stay, okay, stay, all right, and the magnet move up and down, okay, move up and down, and cutting off the like cutting off the conductor also can, as long there is a movement. Okay, so for the induced current to have happened, so you need a movement, okay, whether the magnet move or the conductor move, and there must be a magnetic phase line being cut, so whether it's going up and down. Okay, you cannot like left and right, you cannot move left and right. Okay, so if you move left and right, the magnetic fields will not be cut, so then we know our induced current produced. Okay, so the moving a connecting wire or solenoid rapidly through the space between the magnetic pole. Okay, so the induced current is produced. Okay, so see the video first. Okay, so this is the magnet. This is the magnet. So you can see this is a coil. They made a coil. Okay, so this is the conductor. So you can see you move the coil there, so the magnetic field's being cut. Right? So the direction we keep changing. Okay, it depends on the direction of the current. Okay, so let me, okay, all right. So here, this is the magnet. So this is the north or south. Okay, the north and the south. So there will be a magnetic field here go down like this. Okay, it go down like this. And then after that, you have the coil here, and you just cut it off. Okay, cut the magnetic field. All right. So then you can see the galvanometer is start to deflect. So every time the magnetic field, the galvanometer start to deflect, means the current is produced. All right. So you can see the deflection become larger. Okay, so the induced current is produced in the connecting wire or the solenoid, and it flows through the galvanometer when the magnetic field lines are cut. So see, this is why I said the magnetic field lines are cut, then you produce the induced current. Okay, movement of the magnet. Alright, so the magnetic field lines are cut by the connecting wire or solenoid by moving a magnet. So either then you move the connecting wire or you move the solenoid, you also can produce it by moving a magnet. Okay, so let's see how the, okay, so see this video. Okay, this is a solenoid. Okay, this is solenoid. Okay, so just now you see this the conductor that move, right, that move to the magnet stays there. Okay, but the coil that move, okay, and cut the magnetic fields. Okay, and but for this one, okay, the solenoid, this one we call as a solenoid. Okay, the solenoid stays, okay, but the magnet move. Okay, so when you see when the magnet move, the current will produce. Alright, so that is how the how induced current produced. So whether you move the magnet or you move the connecting wire or the conductor, okay, you can and you cut the magnetic field lines, okay, that will produce the induced current. Okay, but the amount is very small, okay, compared to the one that produced by the power plant. Okay, so let's see the first one. Okay, the electricity generated at the power station. Okay, so the first one is the using the thermal power point. Okay, so thermal power point, thermal power plant. Sorry, so thermal power point. All right. So thermal power point means it's produce electricity by using heat. Okay. So where does the heat come from? Okay, we just burn the fuel or the coal, okay, we burn it, okay, and then the water will be we turn into steam, okay, and the steam has the higher pressure. So the higher pressure of steam, we rotate the turbine, okay, and then the turbine we rotate the generator, okay, and then the generator will produce the electricity here, and then it will be transmit to the transmission power tower. Okay, so the first one I said, so inside of this actually they got a water. Okay, so there's a fuel here, coal, so we burn the fuel or coal. Okay, and then the water will become steam. All right, so when the water becomes steam, steam is a very high pressure. Okay, so the high pressure of steam will rotate the turbine. Okay, and then the turbine will rotate the generator. Okay, and then the generator will produce the electricity and then goes to the transmission tower. But before it goes to the transmission tower, there will be another device here that we call it as a transformer. Okay, this one is to whether to increase the voltage or to decrease the voltage. Okay, so this one we see later. All right, so this is using the thermal energy. All right, so we just burn the fuel and coal and heat up the water becomes steam. The steam has a high pressure, so it will heat up it will rotate the turbine, and then the turbine will rotate the generator, and the generator will produce electricity and will be transmit the electricity to the transmission tower. So let's see how does the energy change, okay, during this process. Okay, the first one is a chemical energy. Okay, it comes from the coal. Okay, and then after that it will burn and it become the heat energy. So this heat energy will turn the water to steam. Okay, and then after that the steam, okay, you already know, has a high pressure. It will rotate the turbine. So anything that move, okay, that will produce the kinetic energy. Okay, so kinetic energy, so the steam rotate the turbine start to move. Okay, so it has a kinetic energy now, and then this kinetic energy will turn into the electrical energy by the generator. So what can you see here? So what can we see is actually the energy is being changed, right? It keep changing the form. Okay, so you already learned the principal conservation of energy, that you cannot destroy energy, you cannot create energy. What can you do is only to transfer or change the form of energy. So this one you can see it changed the form. Okay, so it will not be, cannot be destroyed, cannot be created. Okay, it only can change form only. Okay, so for this one is the thermal energy. So this is the thermal power station. Okay, jadi 12.5.
Ikut aja ni dekat. Ada?
Jadi 12.5 ni sana. So the residue that come from the burning, okay, we use in the construction. So you will not like being wasting like that. Okay, so that is the thermal energy. Okay, so how does it produce? You burn the coal, you burn the coal, okay, and then if we heat up the water changes to steam. Steam has a high pressure, so the high pressure will rotate the turbine will rotate the generator will produce the electricity. Okay, so the next type of power plant is using the solar energy. Okay, so this is called as a solar panel, so it will absorb the heat energy, okay, from the sun rays, okay, to produce the electricity. So maybe some of you, okay, they got the solar panel on the top of the roof, right? So this one is usually used to heat up the water. Okay, so the transformation of energies come from the first one is the solar energy, come from the sun rays, okay, and then after that it changed to the electrical energy. Right. Okay, so I move on to the next one is the hydroelectric power station. So this is the most type of the power station that we use, okay, in our country. So hydroelectric. Okay, so the first we have a water dam here, okay, water reservoir. You can see the position here is higher. So when it's higher, you already when any object, okay, that the position of the object is higher, it will have the gravitational potential energy. Okay, so I give you example. So let's say if I have if your friends stay at the first floor and you live at the fifth floor. Okay, so your position is much higher, right? So means your gravitational potential energy is much higher than your friend that stay in the first floor. Okay, so same like this one. Okay, because it stay in the high position, so mean it consists of the gravitational potential energy. Alright. So when the water come down, okay, when the water come down, it will change the to the kinetic energy. Alright. So here, let me explain first. So the water come down here. So inside here, there is a turbine. So the turbine will rotate. Okay, the water will rotate the turbine here. So then the turbine will rotate the generator. So the generator will produce the electricity and it will transmit to the transformer first. Okay, this one I already explained just now. Okay, to step up the voltage, to increase the voltage, then it will be sent to the transmission power. Okay, so I explain again. So this is the water dam. Okay, so the water will come down. Okay, so this one they consist of the gravitational potential energy. So when it comes down, it will rotate the turbine. So now the turbine moves. So any object that moves, it will have the kinetic energy. So the kinetic energy, then after that, generator also will start to rotate. And it will produce the electricity. Okay, and then the electricity goes to the transformer. So the transformer will step up the voltage and then it will send the voltage, the currents to the transmission tower. Okay, and then we send to the home, to the factory, etc. like that. Okay, so this is the hydroelectric. So let's see the energy change to start from the gravitational potential energy, then kinetic energy, then turn to the electrical energy. Okay, so the gravitational come from here because its position is higher, so it has a high gravitational potential energy. Go down, it turns to kinetic energy because turbines start to move, start to rotate. Okay, and then goes to the and then the generator will produce the electricity. Okay, and then the electricity will send to the transmission tower. Okay, so that is the power station. Electricity generated by using the hydroelectric power station. So you can see there is a it's a very high, right? The position of the water dam is very high. So the water will flow down there. So you see here the position is very high. So means it's produced the gravitational potential energy. Okay. So this is the turbine. So the turbine will rotate. So this is the generator. Okay, so they produce the electricity. So and then the electricity will be transmit uh, to the transformer, and then the transformer will transfer it to the transmission tower. Okay. All right. So the next one, okay, we use the fourth one is the using the the wind energy. Okay, so for the wind is very simple. Okay, so when the wind blows, all right, the blade will rotate. Okay, so when the blade start to rotate, okay, inside of it there will be a turbine. Okay, so the turbine will rotate. Okay, so gear is actually to increase the rotation of the blade, right? Because if you just depend on the wind, okay, it will not rotate do not rotate faster, right? So you have to have the gear so it can rotate faster, right? So here we got we get the turbine to rotate, all right, and then the generator also rotate, and then it will produce the electricity, okay, and then goes to the transformer, and then go to the transmission tower. So basically all is same. Okay, it must have a turbine, the turbine rotate, and then it will make the generator also rotate, produce the electricity, goes to the transmission tower. Okay, but before goes to the transmission tower, they must have the transformer there. Okay, so basically it's just the same, but the first starting point is just different. If you use wind, so mean the wind will blow the blade, right? The blade rotate faster. If you use the water will rotate the turbine. Okay, it will flows, all right, from the high place. Okay, so and then after that it goes down. Okay, and then it will rotate the turbine. All right. If you use the thermal, okay, and then for the thermal you have to burn the coal, okay, and then the coal will heat up the water, and the water change to steam. Okay, so that one is different, but basically at the end all the same. The turbine have to rotate, and the generator also has to rotate to produce the electricity, then it transmit to the transmission tower. Okay, so for the blade is when it start rotating, it will have the kinetic energy. Okay, and then after that it will change to the electrical energy. Okay, so this one is very easy. Okay, so this one I just skip. Okay, I already explained. Okay, for this one is a power station using nuclear fuel. Okay, so we use a uranium. Okay, uranium for this one we use a uranium. Okay, and the uranium we react to produce a nuclear energy. Okay, that nuclear energy we use to heat up the water, and the water will change to the steam here. Okay, then the water will change to the steam here. So this is the uranium. So there will be a nuclear reaction here. Okay, that will produce the nuclear energy. So that energy we use to heat up the steam here. So heat up the water here, and the water will change to steam. Okay, and then the same like the thermal, right? The thermal energy also produce steam, right? So the steam has a high pressure here. But if we compare to the thermal energy and the power station, okay, the power station, the energy of the steam is very, very, very high. Okay, so the turbine will rotate more faster. Okay, so that's why if the country that use the nuclear reaction, okay, to produce the electricity, they don't need so much of the power station, because the nuclear energy when they produce a current, they will produce a very, very large amount of current. Okay, so after that the steam with very high pressure, so the turbine will rotate faster. So when it rotate faster, it will rotate the generator also faster. So they can produce the very high current or voltage. Okay, and then after that, it will we transfer to the transmission tower. Okay, so I explain again. So the uranium, there will be a nuclear reaction here. So the nuclear reaction will produce the nuclear energy. Okay, and the nuclear energy will heat up the water, and the water will change to steam. Okay, the steam has a high pressure, so it will rotate the turbine. Okay, and then the turbine will rotate the generator, and then the generator will produce the electricity that will be transmit to the transmission tower. Okay, so this is by using the nuclear energy. All right. So nuclear energy change to heat energy, okay, and then change to kinetic energy because turbines start to rotate, and then after that you produce the electrical energy that being produced by the generator. Okay, nuclear power station. Okay, so the nuclear reaction will occur at this place. Okay, so they consist of few buildings. All right, this is turbine building. Okay, and this is for the containment building is where the nuclear reaction occurs here. So this one must be a very thicker wall. Okay, okay, so I just skip that one. Okay, so the next one is the power station. Okay, so electricity generated at the power station. So the power station they're using a biomass. So this one they use the biomass and then methane that produce the gas of methane here. All right, and then after that it will burn and the water will be changed to steam. Okay, so the water will change to steam. Again, steam has a high pressure. It will rotate the turbine, and then the turbine will will rotate the generator, and then the generator will send the electricity to the transmission tower. Okay, so for this one it's the same, but for this one they use a biomass. So this one they use a plant residue. Okay, so comes the first energy is the chemical energy, okay, that come from the plant residue, okay, and then they change to the heat energy, okay, that one is used to uh, heat up the water to change it to steam, okay, and then after that the steam will rotate the turbine, okay, and then after that the turbine will rotate the generator, and generator will produce the electricity. Okay, so this is the biomass. Okay, they use the plant residue, okay, uh, as the substance to burn. Okay, like before this for thermal energy they use a coal, right, to burn, and then they burn the coal. But this one they use a plant residue. So you can see when the plant residue here goes here. So this is the they burn the plant residue here. Okay, so and then they boil the water, and water change to steam. Steam goes to the turbine. The turbine rotate, okay, and then a generator rotate, produce electricity. So this is the transformer. Okay, this one is to increase the voltage. Okay, so that is the how we generate electricity. Okay, how we generate electricity. So remember the first one by using the induced current using the magnet. Okay, and then you cut the magnetic field lines. Okay, but that one is the currents are very small. Okay, so for us to use. Okay, so another one by using the power plant. So there are 6 type of power plant. Okay, so you have to know how does each of the power plant, how does it produce the electricity. Okay, and I already explained each of it, so I hope you can understand. All right, and I will stop until here first. Okay, for the next one I will continue for the direct current and alternating current. I will continue I think on tomorrow. Okay, on tomorrow I will continue. Okay, and then, oh no, on Friday, I think. Yes, on Friday, right? So on Friday I will continue on this one. Okay, and we still have 15 minutes. So I want you, for those who still don't turn in your exercise on chapter 5, okay, please, okay, turn in the exercise. Okay, and I will assign to you a new exercise for your tutorial. Okay, for chapter 5. Okay, so we will discuss. Okay, so I put in the GC, in the Google Classroom. Right, so do you have any question you want to ask before I stop? Make sure you the attendance. Okay, monitor, please take the attendance. Right, no. Okay, so I see you. What does the pipe in the nuclear power station do? Okay, the pipe is actually, because you know, right? When the it with the condense, the when the heat, when it's too heat, there will be a water vapor produced there, right? So the water vapor will be transformed back to the water. Okay, it will be the condensation will be occur there. Okay, from the water vapor, because the pipe, when the steam flows to the pipe, all right, there will be the pipe will be hot. Okay, and then will produce the water vapor. So the water vapor will be absorbed back, and then they return back, go back to the water there, then heat it again, and then it goes back, and that's is the like a circle there. Is it okay, Hao Ming? Okay, so if any question you can text me. All right, so I see you on Friday, I think. Okay, so thank you, class. Right, now does the biomass produce biomethane again, please? Biomass produce methane gas. Actually, that one is using the example, the video. The video shows the using the plant residue. Okay, but in the diagram, that one, the methane is using uh, by the how do I say this one? Mm, Animal poops. So they say the cow poops. Okay, so the cow poops is used to produce the methane gas. So if you keep the cow poop in a certain time, it will produce the methane gas. So the methane gas is used as the gas to burn the to make it to burn the, how do I say, like a cooking gas, right? So it's like a cooking gas. Okay, so it will be like a material to burn. Okay, so because the poop, if you keep so long, it will produce the methane gas. So that methane gas will be burned to produce a heat. Okay, and then the heat will change the water to steam. Okay, so that is the difference. There's a many type of biomass actually. The biomass, the one that we see is using the cow poop. That one produce methane gas. But if you use the plant residue, that plant residue we use as a replace, okay, like a coal there, right? Before this, the thermal energy, you use a coal, right, to burn. You burn the coal and you get the heat energy. But this one, you use a methane gas, okay, to burn, and you get the heat energy. Or you use the plant residue and you burn the plant residue to produce the heat energy. Okay, is it clear, Pavandip? Okay, all right, so I see you on Friday. Okay, thank you, class. Okay, bye.